Okay, guys. So here we are. We're going to we're going to do something new. So you should have, let's go ahead and go over to my iPad. So on my iPad, here's what you're going to see. Um, so you're going to notice here that I've got the projectile motion video lab. So all of you guys should have finished this already. And we're going to go over this. So I'm going to give you all the answers and sort of show you what you should have gotten on this lab. This is going to be sort of our debrief of this lab instead of me doing it in front of the class. But at the same time, we're also going to take notes over the lab. So I've got this green note page. Notice this is called Cornell Notes Projectile Lab. So you're going to take Cornell notes at the same time that we go over the labs. You should have both pages in front of you right now. You should have the lab in front of you, and you should have your Cornell notes in front of you. And you're going to write on both at the same time. The Cornell notes are green, so if you see green, you should be writing on your note page. If you see white, you should be writing on your lab. And occasionally we'll flip to Logger Pro as well. So first, let's get started on Cornell notes. So Cornell notes, we always need a topic. Okay, so I'll go ahead and let's zoom in, and I'll write our topic. Okay, so the topic today is going to be projectile motion lab. All right, and then essential question. How does an object in projectile motion travel through the air? All right, so there's our essential question. How does an object in projectile motion travel through the air? So go ahead and get that written down. So there's our topic and our essential question. Remember that your summary at the end is going to answer that essential question. So before we get started on looking at the actual lab, what I want to do is I want to show you guys. So this is what you should have ended up with in Logger Pro. You should have ended up with something that looked kind of like this. So we should see this arc where the basketball, it starts off traveling side to side, and then it gets steeper and steeper as the trajectory falls down to the ground. So hopefully everybody saw something like that. And what I'm going to do real quick, do that, all right, is I went ahead and I took a picture with my iPad. Let's go to all photos. Okay, so I used my iPad to take a picture of the motion. And what I want to do real quick is I want to talk about how there are two different types of motion going on whenever something is a projectile. So the really important thing that we should get here is that we're going to split this motion into horizontal or side-to-side motion and vertical or up and down motion. So what I want to do with this picture, and if you want to just kind of sketch a crude drawing of this, it doesn't have to be perfect. But what I'm going to do is I'm going to mark every, oh my gosh. I'm going to mark every 2 dots on the picture, and we're going to use this every other dot method. Maybe every 3 would have worked better. I don't know. We'll see. Yeah, okay. Let's go every 3 dots. And hopefully what we'll see is we can actually make 2 different motion diagrams based on how the ball falls. So you guys only need about 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If you have 10 dots, you'll be good here, okay? So what I'm going to attempt to do, and I hope this works, is I'm going to try and draw a line straight up from each one of these. So again, I'm just trying to go straight up. And if it's not perfect, that's okay. It doesn't really have to be for us to sort of see what's going on. Oh man, okay, that looks really good. All right, so if we take a look, and I know it's not perfect, guys, but if I were to draw a motion diagram here, what I would do, let's make this blue, okay? I'd put a dot and an arrow, and a dot and an arrow, and we'll go ahead and we'll do this for all 10, okay? So dot, 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 arrow, 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 dot, 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 arrow, 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 and the last one. Okay, so this is really cool. If you look at this now, let's see if I can get it just in the frame. My dots are pretty much evenly spaced, and that's really cool, okay? The horizontal, the side-to-side motion, we're going to see has constant velocity. So notice my dots aren't getting long, or my arrows aren't getting longer, they're not getting shorter. My velocity isn't changing. Okay? Let's write that. Whoops. Let's do this. Velocity isn't changing. All right. Now, if I go and I do the exact same thing, but now I go side to side, okay? So what I'm going to try to do here is I'm going to try and draw a straight line over from each dot. That's super cool. Okay, and now if I go and I do another motion diagram, man, look, I can hardly draw two arrows here. Zoom way in, and I'll make a little bitty arrow. Okay, and what we see is, as I go along, my dots that started off close together are now all of a sudden getting farther apart, and my arrows are getting longer. Oh man, that one's really long. Oh, it's so cool. Okay, so we see that while my velocity didn't change in the side-to-side direction, here my velocity is increasing. All right, that's really cool. Okay, so velocity didn't change side to side, but it increased up and down. All right, so cool. I know that took a little bit, guys, but I really like that demonstration, all right? So now what I want to do is let's go and just talk through the video lab. Okay, so change this back to black. So this says change the vertical axis of the graph to X and sketch the shape. So let me show you how we do that. So this thing here, I make sure that's X. And notice my shape here is going to be this really nice straight line. So what I'm going to do is I'm going to draw that nice line just like that, okay? And it wants to know, why is the graph shaped like that? Well, remember that straight lines, okay, are from constant velocity. Okay, now I was supposed to do a linear fit on there, so let's see what the linear fit is. Looks like I got somewhere around 2.2 meters per second. I think that's pretty close to what a lot of us got. So if you got somewhere around 2.2 meters per second. That's good. So the velocity side to side was 2.2. Now it says, remember that slope represents the velocity. Describe the velocity. So velocity is positive, and it's also not changing. And that's really cool. So that fits right in with that motion diagram that we just drew, is that the velocity isn't changing from side to side. And remember that this is my side-to-side motion here. Now, the velocity graph, now this one might have been tricky for some of us. So let's go look at this. So when I go x velocity, I get something that's really messy looking. Well, here's sort of what happened is I'm zoomed in really, really far. Actually, just double click. And if I go and I change my zoom level, so I went from my top and bottom being about 1 meter per second apart. Now they're 20 meters per second apart. So now I'm zoomed way back, and look at that. I get this nice flat line. Okay? And so that's what we should have seen for this graph. If you drew all those dots all over the place, that's perfectly okay. But really, what I want to see is a flat line, and it should be at about 2.2, okay? So why is the graph shaped like this? Okay, so velocity, remember this is v versus t. Velocity isn't changing. And if it's not changing, it's going to be flat, and we're going to see it right at that 2.2. All right. Now this wants us, okay, so before we move on, I want you to flip back over to your Cornell notes. And let's take a note. So I'm going to kind of divide my paper here. All right, let's take a note about horizontal motion. So the most important thing for us to see about horizontal motion is that the velocity is constant. And I'm going to go ahead and for horizontal, just so we don't forget, remember horizontal is side to side. I think that might be a nice note for you to put in there so you don't forget. So in horizontal motion, the velocity is constant. And if we think about this, okay, it kind of makes sense. Because if we think about Newton's first law, I kind of like these little, look at that, ooh, little firework bubble. Okay, so Newton's first law, what Newton said is that if an object is in motion, so if it's in side-to-side motion, so if it's moving that direction, it's going to keep moving that direction at a constant speed unless a force stops it. Well, we know that when the ball is in the air, there's only one force acting on it, and that force is gravity. And gravity points down. It doesn't point side to side. So it doesn't affect the speed of the ball. So that ball will just keep moving at the same speed until something stops it. And there's nothing to stop it here. So the velocity is constant. Now, I want to go ahead and I want you to put the two graphs on your Cornell note page. Okay? So I want you to go ahead and write position versus time. And let's draw that graph. Okay, so that's going to be t and x because this is side to side. And remember that my position is going to increase at constant velocity. So it's going to be that nice, let me put a little line there. It's going to be that nice flat angled line because remember that the position away from zero is increasing. It's getting farther away from zero. And then my velocity versus time. Velocity versus time. All right. v versus t, it's going to be constant. All right? So velocity versus time, velocity is not going up or down. It's staying the same, so it's staying flat. All right, cool. So let's go back to our lab now. So you're done with Cornell notes for right now. We're going to come back to them in a second. Now this says, now change the vertical axis of the graph to y and sketch what you see. So let's go back to Logger Pro, and it wanted me to change this to y. Now this, guys, this is misleading because it looks pretty flat. We have to auto scale it, and look at that. Now we see that nice curved line, okay? And so let's go back to our questions here. And it said, or first off, let's sketch that. All right, so I've got a nice curved line for my graph. Remember, that is y versus t. And it says, remember that this graph represents the vertical up and down position of the ball. Why is it shaped like this? And so the reason it's shaped like this, remember that curved graph. So anytime my graph is curved, that means that velocity is increasing. That looks like an E, but it's not. It's a C. That still looks like an E. It's not an E, it's a C. There we go. Velocity is increasing. And I'm going to write, it's getting faster. Remember, it's not getting faster side to side. It's only getting faster up and down. Now it says, remember that the slope of the line represents the velocity. Describe the velocity. Okay. So we just said that it's getting faster. But what's important here is that the velocity is also negative. It's negative because the ball is going down. So downward velocity means it's negative. So for the last graph, it wants us to change the vertical axis to y velocity. So let's go change it to y velocity. And I can't see it. That's okay. I'll auto scale. And look at that. So it's got little bitty bumps, but really it's a pretty straight line. So when I go back over to my page, I want to draw a straight line. Now, what you need to notice, okay, is that over here, 0 is up top. All right, so if I were to do something like, let's change this from, say, 5 to -5. We see 0 in the middle, okay? And my velocity, because it's negative, it has to be below 0. So it's speeding up, but it's below the axis. That's super important to see that. So that's where my line should be here. Remember that this is the vertical velocity of the ball. Why is the graph shaped like this? Okay, so we want to say that velocity is negative. And getting faster. And this is going to be an important part, okay? It's getting faster at a constant rate. So it's getting faster at a constant rate, and that means that I have constant acceleration. Getting faster at a constant rate, and that's constant acceleration. So now it wanted me to use the linear fit tool to put a line of best fit on the graph. So I'm just going to linear fit that, and I get -8.47. We'll call it -8.48. So -8.48 meters per second squared. What does the slope of the graph represent? Well, that's the acceleration. And we'll go ahead and put down here that it should be -9.8. So we've got some sort of error here that's causing it to be negative 8.48. I don't know what it was, but it should be negative 9.8 meters per second squared. Because we know that gravity always accelerates things at negative 9.8 meters per second squared. Okay, so you've got the lab done. Let's go now and let's finish these Cornell notes. We're really close to being done. I know this is a long video, guys. So now we want to write down notes about the vertical motion. And that is an R. I know my handwriting gets bad. Okay, so here's what's important about vertical motion. Okay, so velocity is negative and getting faster. That's one bullet point. And my other bullet point should be constant acceleration. And that acceleration is negative 9.8 meters per second squared. Okay? So velocity is negative and it's getting faster, and it has constant acceleration of negative 9.8 meters per second squared. Now let's go ahead and draw the two graphs real quick. All right, so we'll go position versus time. Okay. So that's going to be time, and now it's y. And position versus time is always going to be curved because my velocity is changing. And then we'll write velocity versus time. And this is the one where I have to include 0. So I've got velocity and time. And velocity versus time is going to be below the graph. All right. So there we go, guys. That's it for the notes. First, let's make sure that you guys are writing a summary. All right, you write your summary. Remember that for the summary, we should be answering the essential question of how does an object in projectile motion move through the air? In your summary, you should talk about the horizontal motion, and you should talk about the vertical motion and how they're different. All right, guys, thanks for watching. Not quit air server.